Welcome to our deep dive. We're exploring William James Sidis' 1925 book, The Animate and the Inanimate.
This book really dives into some fascinating physics
It challenges the second law of thermodynamics.
and explores what that means for life, stars, even time itself,
We have an expert with us to guide us through Sidis' ideas.
so you can form your own opinions.
Let's start with the second law of thermodynamics,
It says that energy naturally spreads out over time.
like a hot cup of coffee cooling down.
It goes from concentrated to less concentrated.
This law is fundamental to how we understand the universe.
But Sidis asks, what if this law isn't absolute
What if there are processes that actually concentrate energy?
and reverse the natural flow,
This leads him to the idea of a reverse universe.
where the second law works in reverse and time flows backward,
Imagine seeing a ball rolling up a staircase.
powered by heat energy concentrating in the floor?
In a reverse universe, that would seem normal.
It makes you wonder how different our world would look.
What if broken things reassembled themselves?
What if spilled milk jumped back into the glass?
This really challenges our understanding of cause and effect.
Now, Sidis argues that living things seem to defy this law,
They grow more complex, they maintain order.
while non-living things tend to break down,
It's like a single seed growing into a giant tree.
creating order from chaos.
Sidis says life has a negative tendency.
It actively works against the spread of energy.
He even defines life as bodies with an efficiency over 100%.
Meaning life isn't just a byproduct of physics,
It's a force shaping the universe.
fighting against the second law of thermodynamics.
Sidis then takes this theory to a cosmic scale,
He imagines the universe as a brick model,
with alternating sections.
where the second law either holds true or is reverse,
We only see the sections where it holds true.
because those are where stars emit light.
The sections where it's reversed are dark.
They absorb energy from the surrounding areas,
This makes you think about the Milky Way.
with its bright bands and dark patches.
Could that be evidence of these cosmic bricks?
Sidis even explains temporary stars this way,
They represent a shift from negative to positive,
releasing a burst of energy,
like Nova Persei in 1902.
where a nebula in motion was observed.
Could this explain why some stars appear suddenly?
Now, let's look at traditional star formation theories.
The nebular and planetesimal hypotheses,
They explain stars forming from gas and dust.
gradually cooling and collapsing under gravity.
But Sidis says stars begin in a negative state,
Superheated, nebulous, absorbing energy
and a temporary star flares up,
when it transitions to a positive state.
releasing energy and forming planets.
This is a dramatic shift from traditional views.
Perhaps the most challenging idea from Sidis,
Is that the second law might not be a physical law at all.
but a result of how our minds perceive time.
Think about how we experience moving forward,
Could time only seem to flow one way?
because of how our brains are structured.
If time has no inherent direction,
Then both forward and reverse processes are possible.
it raises the question, is our perception of time an illusion?
Sidis acknowledges that this challenges our understanding.
But it's a fascinating thought experiment. He dives into different chemical compounds and how they relate to these tendencies.
It sounds like chemistry plays a key role.
He talks about exothermic compounds
The ones that release heat when they form,
and endothermic compounds.
the ones that absorb heat,
He suggests the positive tendency favors exothermic compounds.
while the negative tendency favors endothermic ones.
And this leads to an interesting observation about living and non-living matter.
What's that?
Inorganic matter, like rocks and minerals, is mostly made of exothermic compounds,
But living things are mostly made up of endothermic compounds.
like proteins and carbohydrates.
So the type of compound could be a key difference between living and non-living.
He then digs deeper into the chemical composition of life.
What does he find?
He focuses on carbon and nitrogen.
Those are essential elements for life as we know it.
Carbon forms the backbone of most organic molecules.
And nitrogen is crucial for proteins and nucleic acids.
Interestingly, nitrogen tends to form highly endothermic compounds.
Some are even explosive.
So in a universe dominated by the positive tendency, life would favor incorporating as much nitrogen as possible.
That seems counterintuitive given its instability.
Sidis attributes this to life's negative tendency.
Its drive to concentrate energy and defy the second law.
A good example of this are nitrogen-fixing bacteria.
They convert atmospheric nitrogen into usable nitrogen compounds.
This process requires a lot of energy.
It's like they're reversing the natural tendency of nitrogen to stay inert.
Exactly. They demonstrate that life can reverse the second law, at least locally.
So Sidis's exploration of chemistry provides a new way to understand the difference between living and non-living.
He suggests that the types of chemical compounds present could be a key factor.
But he also acknowledges that there might be exceptions.
His insights offer a thought-provoking perspective on the relationship between chemistry and life.
Sidis doesn't limit his theory to life on Earth.
He proposes that life might exist in forms we wouldn't recognize.
Even in environments we consider hostile.
He suggests that life could take on different forms depending on the conditions,
He even suggests life might exist on the sun.
which challenges our understanding of what life needs.
It's hard to imagine anything surviving those temperatures.
While our current understanding of life might limit our perspective.
We need to be open to life adapting in ways we can't imagine.
Yeah, life on the sun would likely be radically different.
What might it look like?
While Sidis doesn't give specifics, he encourages us to expand our thinking.
Life could use energy sources and processes we haven't considered,
This challenges our definition of life.
and forces us to acknowledge its potential diversity.
Sidis also explores the concept of pseudo-living organisms.
What are those?
They mimic characteristics of living organisms but lack the negative tendency
They're like sophisticated imitations of life.
that ultimately obey the second law.
Could you give an example?
Imagine a complex crystal formation that grows and branches,
It might look like a plant or coral,
but its growth is driven by physical processes.
like diffusion and crystallization.
It lacks the ability to actively manipulate its environment.
So they're more like elaborate sculptures shaped by nature.
Exactly.
Sidis suggests these might be common in areas where the positive tendency dominates. They're sort of counterfeit life.
Showing the universe can create complexity even without true life.
How can we tell the difference between true life and these pseudo-living organisms?
Sidis argues the key is their relationship to the second law.
True life reverses it, showing the negative tendency.
While pseudo-living organisms obey it,
Observing their energy flow and ability to create order could provide clues. But distinguishing between them might not always be easy.
especially in environments very different from our own,
This emphasizes the need for an open mind.
and a willingness to expand our definition of life.
Sidis's concept of pseudo-living organisms adds complexity to his theory,
It challenges us to consider the universe might be full of things that mimic life.
while ultimately being distinct from it.
Now let's explore Sidis's idea that our perception of time's flow might be an illusion,
He suggests time itself might not have a direction,
but exists as a two-directional dimension.
like the three dimensions of space.
This challenges our experience of time moving forward.
Sidis argues our perception of time's flow comes from how our brains work.
He compares it to our perception of spatial dimensions.
We can move freely in any direction in space.
But we experience a clear difference between forward and backward in time.
So he's saying this distinction might be a mental construct,
He proposes our brains are wired to perceive time flowing in one direction.
maybe due to how our memories form or how our nervous system processes information. If time doesn't inherently flow one way,
Then are the concepts of past and future illusions?
Sidis suggests they might be, from a physical perspective,
If time is two-directional, then all moments might exist simultaneously.
like all points in space exist simultaneously.
This challenges our idea of time as a linear progression,
Sidis acknowledges this is difficult to grasp,
because it contradicts our experience.
but he encourages us to consider that our perception of time might be limited.
He uses the analogy of a four-dimensional loom to illustrate this,
Imagine a loom where threads are interwoven.
representing all the events and moments in the universe's history.
Each thread is a specific event or moment,
Our consciousness is like a film moving through this loom.
creating our experience of time as it passes through different cross-sections.
This helps visualize how all moments might coexist.
Even though we only experience a narrow slice,
Sidis emphasizes this is just an analogy,
it's hard to truly understand a two-directional time dimension.
but it highlights that our linear perception of time might be due to our limited perspective.
This exploration of time is one of the most challenging aspects of Sidis's theory,
It forces us to confront the limits of our perception.
and consider that our understanding of time might be flawed.
It's important to note that Sidis doesn't give definitive answers.
He presents his ideas as thought experiments
He acknowledges these concepts are speculative.
and might seem counterintuitive. But that's what deep dives are for.
We explore unconventional ideas that challenge our assumptions
Sidis's work encourages us to question what we think we know.
and embrace the possibility that the universe is stranger than we imagine.
But if life reverses the second law,
Shouldn't we see more evidence of this in our world? It's possible the evidence is subtle and we haven't noticed it yet.
Maybe we're not looking in the right places.
Our instruments and methods might not be sensitive enough.
Or our assumptions about the second law could be blinding us.
It's also possible the negative tendency is localized.
Stronger in some parts of the universe than others.
We might need to look at smaller scales or specific processes.
So the search for evidence needs to be more focused and open-minded.
We should study living organisms closely.
And look for processes that seem to defy disorder.
Sidis's theory hasn't been without its critics.
What are some of the objections?
One is that his reverse universe clashes with our idea of causality.
Cause and effect should always go in one direction.
It seems paradoxical for effects to precede their causes.
So how does Sidis address this?
He argues that our concept of causality might be tied to our linear perception of time.
If time isn't linear, then cause and effect might be more complex.
In a two-directional time dimension, they might be interconnected.
Another criticism is that his theory lacks testable predictions.
It's difficult to verify or falsify scientifically,
So it's more of a philosophical framework than a scientific theory.
but it can still inspire new research and approaches.
It might lead to testable predictions in the future,
Another objection is the lack of evidence for life in extreme environments.
like on the sun or in space.
Sidis argues that our search for extraterrestrial life is limited,
We might be looking for life as we know it.
and missing life as we don't know it,
He encourages us to broaden our definition of life.
and consider possibilities beyond our current understanding.
What about his concept of pseudo-living organisms?
Critics argue that the distinction between true life and pseudo-life is arbitrary.
There might not be a clear scientific basis for separating them.
Sidis maintains that the key is their relationship to the second law,
True life reverses it,
while pseudo-life obeys it.
but observing this difference might be challenging.
It requires careful study of their energy flow and organization,
The debate highlights the difficulty of defining life itself.
especially when we consider its potential diversity.
The criticism of Sidis's ideas about time focuses on the lack of scientific evidence.
Our experience of time seems to contradict the idea that it doesn't flow forward.
So his proposal remains speculative,
But it prompts us to think differently about time.
and its relationship to our consciousness.
Stepping back, what are the broader implications of Sidis's work?
He challenges our understanding of the universe.
He questions fundamental laws and offers alternative frameworks.
He reminds us that scientific progress often involves challenging dogma.
And considering new perspectives,
Sidis also highlights the interconnectedness of life and the cosmos,
he sees life as an active force shaping the universe.
not just a passive byproduct.
He elevates the importance of life in the grand scheme of things.
Sidis's work is a testament to intellectual curiosity and exploration.
He encourages us to question our assumptions and embrace the unknown.
His legacy lies in his thought-provoking ideas and his spirit of inquiry.
He reminds us that the universe is full of mysteries waiting to be discovered.
Thank you for joining us on this deep dive into the work of William James Sidis
We hope this exploration has sparked your curiosity.
and inspired you to think differently about the universe and our place in it.